Now that we've got our Raycast refactored, we're going to pause and take a quick look at performance. There's actually a good opportunity for some simple optimization and a good explanation of some of the things that are changing with the 2D physics system. So let's take a look at our character here. I can run around and jump, and I can see that it's working fine. I've got my double jump and all, but I want to look at how it's actually performing. So I'm going to open up the profiler. I've got the tab here, but if you want to open it, you go to Window and then go to Analysis and Profiler. That'll bring up the profiler window. I do have deep profile turned on. You're going to want to stop playing. Make sure that you go to the profile mode and turn on deep profile. It turns on, it gets that little, the Unity visualization, it's off, and now it's turning back on. With deep profiling on, I can get performance characteristics of every single line of my code, not just at the top level. If I don't have deep profiling on, I won't get full info about what's going on. I'm going to press play now. And when I say full info, I'll get things like the update for player took how much time, but it won't tell me how much each sub method that got called from inside of there. If you enable deep profiling, it's going to give you the entire stack trace all the way down. So I'm going to go into profiler. I've got my game running right here. Go to the profiler tab right here, and I'm just going to click on any old random frame. I know that I call my grounding code and all the raycasting stuff every frame, so I don't really need to care which frame I'm on. But if I scroll through here and I just look at the overview down here at the bottom, let's drag this up here to the top. So I've got CPU usage and rendering showing. I don't really care about rendering. Yeah, so I'm just going to drag this all the way up. So just CPU usage is showing. Here's a scroll bar on the right hand side that allows me to go through all of the different things that are being profiled. Again, I'm going to go up to the top and just select CPU usage and grab a frame here. Down in the hierarchy, if you don't see the hierarchy and you see it as a timeline or maybe as a raw hierarchy or something, just make sure that you go select hierarchy. And then if you don't see the thread correctly, it should be on main thread unless you went and selected something else. Then scroll up to the top and we're going to sort by time. So just click time MS right here so that the arrow is pointing down and the thing with the highest time is at the top. We can see right up here at the top, we have our update script run behavior update. This is our code being run. This is our own scripts being run. And underneath it, we've got the behavior update, which is the update method for all of our scripts being called. If I expand that out, you'll see that it's calling player update, debug updater, event system, blaster shot, and some cinemachine updates. So all of these things have an update in them. The only one that's taking a good amount of time and doing this GC allocation, which is our garbage collector allocation, is the player update. If I expand that out again, you'll see that it's actually all inside of the update grounding method, and I can expand that out again. I just use the right arrow and down arrows, by the way, and I can see that check grounding is doing it. I can keep expanding out and see that the biggest impactor right here is the debug.log. That's usually the case. If you have a debug log, it's going to destroy performance. So I'm going to remove that. And then let's take a look at what else we can remove though, or what else we can change. If I go down a little bit further, you can see that much smaller, but still there as an issue, is the physics 2D raycast all method. If I expand that out, you can see it's calling raycast all internal. It's allocating some memory. The GC alloc means that it's creating objects that are going to have to be cleaned up later, and it's taking a little bit of time. Now the time amount here, I'm not too worried about. It's 0.02 milliseconds. It's not horrible, but the allocations I don't want happening. So we're going to fix that as well. Let's stop playing and go look at the code now. In our code, the first fix and the biggest one is to just get rid of this line 177. I'm just going to comment it out with my 2 forward slashes. The next thing that we want to do though is change this raycast all. Instead of using the raycast all method, we want to use one that doesn't allocate memory, one that just reuses or restores off an array of things that it's hit and then fills that. The reason for that is, again, so that we don't have to have objects that are being created and destroyed every single frame, because that causes memory fragmentation, eventually causes garbage collection, and then that causes a freeze or a pause or a hitch on your game, depending on the system that you're on. But if you're not on a high-end system with fast memory access, you can expect that to happen. So you want to minimize these allocations. Now to do that, we've got a couple options. We can use the raycast all non-alloc that appears as an option, but what we actually want to do is switch back to raycast. And that's because the way that the physics system is being updated, the raycast method is getting a bunch of overloads, and the raycast all and raycast non-alloc, in fact, all of the non-alloc overloads or methods are being removed or deprecated. And we can see that easily by, let's just go put the raycast non-alloc here and hitting F12. If I hit F12, it's going to show me the decomiled code in my code editor. And this shows me that it's marked as exclude from docs. And if I actually go look this up in the documentation, you'll see that it does say that it's going to be deprecated soon. So what can we do? Well, what we can actually do is use one of these raycast overloads. If I look right above it, you see there's a raycast that takes an origin, a direction, a contact filter, and it has a list of results, or there's one up here with an array of results. So I can use one of these two methods as my thing, or my call, and then pass in the list or array of results. So let's go back and rewrite this. We're going to just add a new line, and I'm going to say int hits equals physics2d dot raycast, and we'll do the open parentheses, and I believe it's overload 4, so I'm just going to hit the down arrow until I get to the fourth one, and I can see it. Oh, is it 4? No, it's number 5. So I know that the first parameter is my origin. I'll pass that in. Then our direction, which is vector2 dot down. Then we've got our, let's see if I can find my overload again, overload 5, our contact filter. So let's just do a new contact filter for now. And in that contact filter, we'll set the layer mask equal to underscore layer mask. And then our next parameter for the raycast is going to be the results. So do underscore, and, is it? Actually, let's make sure that it's results. Go down to number 5, yes, results. So raycast hit array. Let's call this underscore results. And then finally, we need our distance, which we've used a 0.1. So we'll use a 0.1 for this as well. I'll put the semicolon at the end. And then I'm going to get rid of line 165, and we'll generate the results field. We'll hit Alt-Enter and generate a variable for it. Hit F12, we should have a private raycast array right here by our player data. I'll get rid of the private keyword, and then we're going to initialize the array to be a new raycast hit 2D array, and give it a size of 100. That's way larger than we'll need. We're never going to have 100 colliders that we hit. So if we have more, we'll just over allocate it by quite a bit. It's still a tiny amount of memory, but way more than we need. All right, let's go back to our code. I'll just hit the back button a couple times. And I'm going to split this raycast into a few lines because I feel like it's a little bit harder to read now because we've got our contact filter in there. So let's just split this all into new lines. And then instead of looping through each hit, we need to do a for loop because hits is now an integer and not a collection. And now we have an array here of results, but if we looped through all of these results, we'd be looping through a bunch of empty entries every time because it's got 100 entries there and it may or may not be filled. The raycast method is going to tell us how many things were put into the results array, so we can just loop through that many times. So we'll replace our for each with a for loop by typing for. I'll hit tab a couple times and replace length with hits. Then I'll delete out the brace here on 173, the for each loop, and that brace again on 173. And then we'll add a new line here and just say var hit equals underscore results at index I. So we give it the braces, and now we're looping through all of our results and assigning their first result to hit, checking it, and then assigning the next result to hit and checking it, and so on. So we're looping through them all without creating a new array. We're now should be running this without allocating any extra memory. Let's save, go into Unity, and try it out and see if our change worked and if our performance is improved. All right, we're back in Unity with the profiler running. I'm going to go over here. We'll just find a random frame. And we can look here at check grounding and see that it is now allocating 0 and taking 0.02 milliseconds. The raycast has shrunk down just a little bit, and we've got 0 allocations. Things are looking good. This is, again, a nice, easy optimization and something that we should do on anything that we're doing a raycast for that's continuous. If we're doing a raycast every frame, it should almost always be non-allocating. In fact, there's almost no excuse not to use one that doesn't allocate. The overloads are there and they're kind of the default. So go with that on anything where you need to raycast continuously or where you're just going to do it often enough that the allocations are going to matter. So now that we've got that change in, I think I want to go into plastic and commit our changes. I've also got some extra junk here of just cleaning up and version updating. But let's say that let's do a diff real quick. We'll pull up the player, we'll diff. And I guess the only note here will be that we've switched to raycasting, a non-allocating version of raycasting. So switched ground check to non-allocating raycast.